Okay, so today I wanted to talk about tubuloglomerular feedback. And so this is mainly going to have to do with when you have low or high blood pressure. And so if you have low blood pressure, then you're going to dilate your afferent arteriole. And so what happens with that is, so the macula densa kind of regulates this whole thing. And it does this by monitoring the afferent, And it does this by monitoring the afferent arteriole. So you have your macula densa cells and they're pushed up close to your afferent arteriole, which is here, and then you got your efferent arteriole of the glomerulus, right? There's your capsule. So what the macula densa does is, if we have tubular fluid here, sodium chloride here, it's going to monitor your concentrations of sodium and chloride within the blood. And so if they're too low, what is going to happen is then paracrine is going to be released from the macula densal cells to dilate this afferent arteriole. And what that does is it brings more sodium chloride in. It also increases blood pressure in the arteriole. So really you can't monitor water, but you can monitor salts. So if you have low salt content, then there's not going to be water following into that for osmosis. So the macula densa cells say, hey, dilate, we need more volume in this afferent arteriole. So the macula densa cell monitors that. It can also do the same thing with high blood pressure. If you have too much volume in the afferent arteriole, then it will dilate that. And so that's important in monitoring filtration, which I discussed in a previous video. On a cellular level, though, the macula densa, it will monitor. Oh shoot, where did it go? I had another drawing here. The macula densa cell will monitor all of these things. So if we see here sodium, macula densa cell is going to monitor this, and it's going to establish balance. So what happens with that? Well, say you have low blood pressure, you want to increase it. The RAAS system, or the renin aldosterone angiotensin system, is going to kind of help with that. And so if we have a low glomerular filtration rate, angiotensin and renin, renin will stimulate angiotensinogen, which will turn to angiotensin 1. ACE from the angiotensin converting enzyme from the lungs will convert that to angiotensin 2. Then angiotensin 2 is going to go to various parts of the body, like the kidney, your adrenal gland, your blood vessels, such that you can increase blood pressure. So in the case of the adrenal gland, that increases aldosterone. Aldosterone increases your sodium-potassium pump activity, so you're pumping sodium out, and that's why the macula densa cells are so important, is they'll monitor that sodium chloride concentration in the blood. So that's why renin is secreted because of that macula densa cell, to monitor all that. And then ADH will increase, which will make you feel thirsty, and ADH at the end of the day will put aquaporins within the collecting tubule here. so that more water is absorbed back into the blood. It's also a signaler to the brain saying, I'm thirsty, I need more water, so you drink more water. Angiotensin 2 will also hit your kidneys, which will constrict your efferent tubule or arterial. And yeah, I believe that is essentially a basic summary of the RAAS system, renin, angiotensin, aldosterone system, how that all works. On the cellular level, ADH will hit neurons, which will stimulate baroreceptors and cause synapses to happen such that your blood pressure either goes up or down. Okay, and that's what happens with, well, let's look over here for ADH and aldosterone. Just on a cellular level, here's your collecting tubule. You have ADH is going to stimulate aquaporin insertion into your cells, which is going to pull water out of the cells, or rather across the cells from your collecting tubule into the blood over on this side. If I said aldosterone, sorry, I meant ADH is going to do it stands for antidiuretic hormone. That will cover your aquaporin appearance. Aldosterone, on the other hand, it points to this sodium-potassium pump. You're just going to pump more salt out into the blood so that water will follow into the blood. So that's important for increasing your blood pressure altogether. And that sums up tubular glomerular feedback. The macula densa cells monitor that sodium chloride concentration within the blood. The RAAS system, as we saw over here, will secrete ADH and aldosterone, which also will raise our blood pressure by inserting aquaporins for ADH, or increase our sodium-potassium pump, increasing the sodium chloride concentration in the blood. And then, yeah, at cellular level, this is just the effects of aldosterone and ADH, what it does to an actual cell within the collecting tubule. So there you have it. That's tubuloglomerular feedback and the RAAS system, as well as some of the roles of ADH and aldosterone.